So you are here because you want to learn about triangles today, or you are here because you know that sometimes there is extra credit in the videos. And today the extra credit is at the beginning. So I would love to know what you think the most awkward way you could greet somebody would be. So what is the most awkward way you could greet somebody? Email me and let me know that. Or a funny, awkward way to greet somebody. I think that just staring awkwardly and waiting for them to greet you is pretty crazy, but I want to hear some good ideas from you guys, okay? So we're going to talk about classifying triangles today to start with, and the first way you can classify a triangle is by the lengths of its sides. A scalene triangle has no congruent sides, an isosceles triangle has 2 congruent sides, and an equilateral triangle has 3 congruent sides. The other way you can do it is by the angles in the triangle. So an acute triangle has 3 acute angles, so 3 angles that are less than 90 degrees. A right triangle has 1 right angle. An obtuse triangle has 1 obtuse angle. And an equiangular triangle has 3 congruent angles, or 3 of the angles that are the same. And an equilateral triangle is always equiangular, and an equiangular triangle is always equilateral. Those two things always imply each other. So if it is one, it is the other. And a lot of times we'll classify a triangle by its sides and by its angles. And so I'll ask you to give it 2 names. So it could be an obtuse isosceles triangle or a scalene right triangle. But if it's equilateral, it's equiangular, and there is no other classification that you can stick with those, except maybe if you wanted to call it an acute equiangular equilateral triangle, but it is more specific if you just say equiangular. So this triangle that is formed in this bridge has 2 sides that are congruent, and we know that because of those marks right there. And we see that these angles all appear to be less than 90 degrees. So this would be an acute isosceles triangle. We can also draw triangles based on the description. So we want to draw an obtuse isosceles triangle to start with here. So obtuse means it has 1 obtuse angle, and isosceles means that it has 2 of the same length sides. So this is what my obtuse isosceles triangle looks like. And this would be the obtuse angle that is greater than 90 degrees. Now I'm going to draw an acute scalene triangle. So I want 3 side lengths. Needs to be acute. And I'm just going to say, even though it looks like some of those sides might be the same, we'll label them to show that they're all 3 different lengths. And that these are all little acute angles, but they're all different. Okay. All right. So we also try to classify triangles on a graph by their angles and their sides. So we're going to start with the sides here, and then we'll determine whether it's a right triangle, because that's how we're going to classify it by its angles. So to figure out what kind of classification it's going to have by its sides, we have to know the length of all the sides. And on this one, there is no sides that go along those lattice points and along the grid lines, and so we have to actually use the distance formula. We're going to have to use it 3 times, once to find the length of PQ, once to find the length of QO, and once to find the length of OP. So we are going to start with PQ. So I'm going to use the distance formula, if you remember the distance formula. I'm going to do 6 minus 1 squared plus 3 minus 2 squared. And so this is 6 plus 1, so that's 7 squared. And 7 squared is 49. And 3 minus 2 is 1. 1 squared is 1. So the length of PQ is the square root of 50. And we could simplify that square root, or we could get a decimal approximation. It's approximately 7.1. Okay, now we're going to find the length of QO. So remember, do the distance formula again. So we're going to do 0, take away 6 squared plus 0, take away 3 squared. Then I'm going to simplify that. So negative 6 squared is 36. Negative 3 squared is 9. So this is the square root of 45, which is approximately 6.7. And then we need to also do that for the length of side OP. So again, distance formula. So negative 1 minus 0 squared plus 2 minus 0 squared, which gives me negative 1 squared, which is 1. And 2 minus 0 is 2 squared is 4. So 1 plus 4, which equals the square root of 5, which is approximately 2.2. So really what we've gotten from this are 3 different side lengths. And so if a triangle has 3 different length sides, then that means that triangle OPQ is a scalene triangle. Okay. The other thing that we have to do here now is determine whether it's a right triangle or not. And so to do that, what we have to do is look at the slopes. This is going to be the best way to figure out if it's a right triangle. So we're going to find the slope right here of PO. So the slope for PO, I'm going to go down 2 and over 1. So negative 2 over 1, which is negative 2. Because this is where it looks like that right angle would live if there is one. And then I'm going to find the slope of OQ. And so you go up 3 and over 6. So 3 over 6, which is 1/2. They are opposites and they are reciprocals, which means they are perpendicular. So it is a right triangle. So it is a scalene right triangle. And then actually the better way to say that would be a right scalene triangle. The other way we could do it is by using the Pythagorean theorem. We could actually use these lengths that we found right here, the square root of 50, the square root of 45, and the square root of 5, and plug them into the Pythagorean theorem to see if this is a right triangle. So that would be the 2 legs, which are the shorter sides, squared should equal the hypotenuse, which is the longest side, squared. And so then we get 5 plus 45 equals 50, and that works out because 45 plus 5 is 50. And so this also shows that it's a right triangle, as does this. So either one of these methods will work. Usually the slope method is probably the most straightforward because you don't have to be doing the using the distance formula unless you've already done it. All right, moving along. The angles of a triangle always add up to 180 degrees, and hopefully that's not news to you that you've heard that before, but if it is, just make note. So whenever you add up all 3 angles in a triangle, it will always equal 180 degrees. 180 degrees, that's the sum of the interior angles of a triangle. Don't forget that. So using that idea and knowing also that a straight line equals 180 degrees, there's a theorem called the exterior angle theorem. So the measure of an exterior angle of a triangle is equal to the sum of the measures of the 2 non-adjacent interior angles. Okay, that's a lot of words. What that means is if you extend one side of a triangle out, you create this angle on the exterior. Okay? And we know that that angle is equal to the inside angles or the interior angles that are not touching that angle added together. So you would take the measure of angle A plus the measure of angle B, and that would give you the measure of angle 1. The reason this works is because a triangle adds up to 180 degrees. And we know that this angle 1 and angle C would be supplementary. So it would be like angle A plus angle B plus angle C equals 180. And we also know that angle 1 plus angle C equals 180. So you can use the transitive property and almost prove this right here and say A plus angle B plus angle C equals angle 1 plus angle C. And so if you subtract angle C from both sides, you get that angle A plus angle B equals angle 1. So that's why this works. All right, but just know that these two angles added together are going to give you this exterior angle. So now we're going to use those two ideas to find missing angle measures. So if we know that these add up to 180, we could do angle 1 plus 40 plus 30 equals 180, but I'm going to guess that you guys have all figured out already in your head that the measure of angle 1 is 110 degrees, because 110 degrees plus 30 plus 40 equals 180. Okay, on this next one here, we use the same idea, and we know all the angles in a triangle, all the interior angles add up to 180, so I can take 6x plus 7 plus 11x minus, oh goodness, minus 2 plus 90 equals 180. Okay, I can combine my like terms here, so I get 17x, and then 7 minus 2 is 5, plus 9 is plus 95 equals 180. So 17x equals 85, and so x is equal to 5. Okay, so we can use the fact that there's 180 degrees total in a triangle, and that gets you the missing parts. Now we're going to use that exterior angle theorem, and we're going to find what angle 1 is after we solve for x. So the first thing we need to do is figure out what x is so that we can find the measure of angle 1. So I know if I take these two interior angles and set them equal to this exterior angle, then I can use that equation to solve for x. So I get 2x minus 10 is 40, so 50 is equal to 2x, so x is equal to 25. Okay, but again, that's not what is asked of us. And so we need to use 25 then to figure out what the measure of angle 1 is. So I see this right here is 5 times x minus 10. So I know that this angle here is 5 times 25 minus 10, which is 115. I also know that this 3x, this angle here, ends up being 75 degrees. So now I can use either of those pieces to help me. I think it's easiest to use this. If I know these are supplementary angles, so the measure of angle 1 plus 115 degrees equals 180 degrees. So the measure of angle 1 is 65. You could also add 75 plus 40 plus measure of angle 1 and set it equal to 180, and you would also get that that's 65 degrees that way. Okay, so for two figures to be congruent, all of the angles and all of the side lengths have to be congruent. So these two triangles are congruent because they have 3 sides that are marked as the same, and they have 3 angles that are marked as the same. And so we can write a congruent statement. So if I'm just going to start with the angle that is labeled with a 1 mark here, so I'll erase all of my stuff. So this is triangle LJK is congruent to triangle, and I have to do the same order. The order matters here. RTS. Okay, so corresponding parts have to be labeled in the same order. All right, so I would like you to try and list all the corresponding parts and try and solve for the value of x here. So pause the video. Okay, so you should have 4 congruent angles and 4 congruent sides, and you can use this congruent statement up here and the diagrams to help you write those congruent statements. And then to find the value of x, h is congruent to f because those are corresponding parts of those figures, and so you can use those then to solve for x. Okay, there's 7, 8, and 9, and then a challenge as well listed on the notes. I am running out of time, and I would like you to look over those to try those and check your answers with the notes. Please let me know if you have questions and make sure to email me your awkward greetings.